Assalamu alaikum everyone. Let's start the 7th lecture for CS 116 Object Oriented Programming. Up till now in Python we have seen how to create classes, how to instantiate objects or instances. We also discussed the concept of namespaces, that what happens in the background when a program containing classes and objects runs. And we also studied these three types of variables that you can define in a class: instance variables, class variables, and local variables. The main topic for today is what support does Python provide for implementation of access modifiers. Now the problem here is that Python does not directly support uh, access modifiers. It does not provide any keywords or syntax for them. But there are other features in Python that can be used to implement the concept. Now Python uses underscores in a lot of different ways. And one use of using these underscores is to resolve name conflicts, and that is called name mangling. So we'll discuss the concept of name mangling today, and then we'll see that same underscores, they can be used uh, to implement the concept of access modifiers by a programmer if he or she wants. And we'll see some code examples to explain all these concepts. These are the 5 variations in which underscores can be used in Python. If you see the central column of example, var indicates a variable name. Here you can see at some places a single underscore has been used, and at some places double underscores have been used. And somewhere these underscores, they are placed before the variable name, and at some places they are placed after the variable name. And if you see the third option, there we are using underscores at both places, before and after the variable name. So each of these cases, they indicate a different scenario. So let's discuss them one by one. Now the first case is of single leading underscore. So if you are placing a single underscore before a variable name, before an attribute name, or before a method's name, then what does it mean? That attribute or method is meant for internal use only. Like Python does not enforces this through the interpreter. And by that I mean that if you try to access such an attribute or a method from outside the class, then Python does not generate any error. But this notation, it's just there to hint the programmer that this is reserved for internal use, so kindly do not use it in your main program. There is only one case when Python puts some restriction on such kind of method names. Let's suppose you are starting a method's name with a single underscore. Then those methods will not be imported when you use that import command with a wildcard. Now, wildcard means static. I hope you remember that we can import functions and classes from a module using from and import keywords, like from module import static. So that would import all the functions and classes from that particular module. But if you are using some methods in that module which are starting with this single underscore, those methods won't be imported through that command, right? Apart from that, Python does not raise any error when you try to access such methods. It's just a kind of hint or understanding between the programmers that if a method name or a variable name starts with a single underscore, that is for internal use only, and that should not be accessed from outside the class. Case is when you put a double underscore before a variable name. Uh, that variable name could be name of an attribute, or it could be name of a method, right? So when you do that, Python triggers name mangling, and name mangling is the concept that we'll be discussing right after this slide. So let's leave it till then. Now the third case here is when we put a double underscore before a variable's name and also after that variable's name. And again, this variable name, it could be an attribute's name or it could be a method's name. In both cases, it signifies that these are special attributes or special methods that are used by Python at special occasions. And such methods, these double leading and trailing underscore methods, they are called dunder methods. And these dunders, they are the topic of our next lecture. Okay, the last two, they are not really important to us right now, but for the sake of completion, let's see what they do. Um, if you use a single trailing underscore, like you place a single underscore after a variable's name, then that is used to avoid naming conflicts with Python keywords. For example, you have selected a variable name that is also a keyword, and that variable name suits very much to the scenario in which you are using it, and you don't want to change it. So what you can do, but you cannot use it like as it is, because it will be taken as a keyword by Python and it will not work the way you want it to. So what you can do, you can just place a single underscore after that variable name, and that will differentiate it from the regular keyword. The last one, here you are using only a single underscore. You are actually not using any variable name here. So this single underscore is used for temporary variables. Like you can use it as a loop counter, which finishes after some time, and then you won't be needing that variable again. So you can use this single underscore there, right? Now, out of these five conventions, these two which I have highlighted in gray, these are the ones for which Python takes some concrete action. Like if you are using this double underscore before a variable name, Python will expand it to some other name. We'll see that shortly. And if you are using dunder methods, then Python will execute some special functions or methods at the backend for these dunders. But apart from these, the remaining three, they are mainly conventions. Like they are a kind of soft message for the programmer or for the user of that class. If you use these conventions, that is good. But if you are not using them, then also it's not an issue. I just told you that if you place a single underscore before a variable's name, that triggers name mangling. So let's see what name mangling is. Uh, when we define a class and we inherit a child from that class or multiple, classes from that parent class, what might happen, that a programmer might use same variable name in different classes. So we know that separate namespaces are created and they should not interfere with each other. But the way Python stores them at the back end, that sometimes causes intermingling of those names. So name mangling is the a method which helps Python avoid these such naming conflicts, right? So what Python does, uh, it changes that name into an extended name. Like whenever Python encounters a variable name that starts with a double underscore, Python replaces that name with an extended name. We'll see that shortly, that what that extended name is. If you want, if you are coding a class and you want a variable name to be unique throughout, what you have to do, you just have to place a double underscore in front of it, right? Then Python will take care of it and Python will make it unique throughout. So what Python does here is it simply concatenates class name as well with the variable name. Like it makes the name longer, double underscore variable name, and Python places class name before this convention. So class name along with the variable name makes it unique and differentiates it from same variable name defined in other classes. So here is an example. For example, you are using double underscore var. Var is the variable name. So this is the variable name that you have chosen. And since this variable name is starting with a double underscore, so whenever Python encounters this name, it replaces this name internally with an expanded name by concatenating class name in front of this. So the new name will be underscore class name double underscore var. Now this is the format. Here class name is the name of that class in which that variable is defined, and var is that variable name, and this single underscore, and then at third place a double underscore, that is part of syntax. So whenever Python encounters a double underscore variable, where double underscores are used at the leading place, that name is converted into this extended name. Now, one important point here is that if you are defining variable names this way, like using leading double underscores, then such variables, they are not accessible from outside world. Like you cannot access them directly from your main program. If you want to access them, you will have to use that extended name. Then it can be accessed from the main program. Otherwise, in normal form, it cannot be accessed from the main program, or you can say it is invisible to the outside world. Now, this property enables us to use this naming convention to emulate private access modifiers, and we'll see that shortly. Now, having discussed the use of underscores and name mingling concept, now let's come to access modifiers. Uh, First, let me recap these access modifiers quickly for you. There are three access modifiers: public, private, and protected. If you are making an attribute or a method public, actually all methods and attributes, they are public by default. That means that they are accessible from everywhere. By everywhere, I mean they are accessible from within the class where they are defined. They are also accessible from any child class, and they are also accessible from the main program where we are instantiating objects, right? Now, if an attribute or a method is private, then that means it is only accessible from within the class where they are defined. Attributes and such methods, they are not accessible from any child class, and they are even not accessible from the main program. And if an attribute or a method is protected, then it is visible to the class where they are defined, and they are also visible to the child classes, but they are not visible to the outside world or to the um uh, in the main program. So in essence, these access modifiers, they are implementing data hiding concept. Like if you are making an attribute or method public or private or protected, that means that you are deciding on accessibility limits for those attributes or methods. Like you are giving a controlled access to the outside world on your on different components of your class. So what happens in classical object-oriented languages such as C++ and Java? These access modifiers, they are exactly implemented the way I have explained. Like if you are making an attribute protected, it is only accessible from within the class and from child classes. It is not visible to the outside world. And same is the case for private attributes and methods. Uh, and what these languages do, they provide special keywords to enforce this accessibility. Like in Java and in even C++, public, private, and protected, they are actual keywords. Whenever you want to make an object, an attribute or a method private or public or protected, you just use that keyword before the name of that method or attribute, right? And it strictly implements the concept. These languages, they strictly implement the concept of access modifiers. But Python is different in this regard. Python developers, they think that a code or part of code, it should not be hidden from other programmers. Every programmer who is using a class, he should have complete access to all the components of that class. So Python does not provide any regular syntax or keywords to implement these access modifiers, but uh, we can emulate the behavior of these access modifiers using some of those underscore conventions, right? So the point here is that Python does not support access modifiers concept, but there are ways in Python using which we can emulate the behavior to some extent. So let me show you that through some examples, and that will help you understand the concept of access modifiers as implemented in other languages. Now we know that all the attributes and methods, they are public by default in a class. And by public, I mean that they are accessible from everywhere, from within the class, from child classes, and from the main program. So we have been using classes this way since beginning, but let's do an additional example for the sake of reinforcement. Now let's define a new class called test public, and the sheer purpose of this class test public is to demonstrate the accessibility of public attributes and methods. So here I'm not declaring any class variables or class attributes. I'll define only one attribute, and that is going to be an instance attribute. Now this is my first method. This is a public method by default, and it's a setter method. And here what I'm doing, I'm setting an attribute, and the name of that attribute is public attribute, public attr, right? Now since I'm not using any special convention, that means that it's a public attribute. So this is a setter function, setter method for that public attribute. Here is a getter method for the same attribute. So we know this self convention, self.public attribute means that this is an instance attribute, and getter method will read the value of this attribute, this public attribute, and setter function will set a specific value for this public attribute. Now let's define a third function, and I'm calling it a public method. And of course it is a public method by default, and what I'm printing here is I'm simply printing a statement, I am a public method. Now let's run some test code. This is the first statement. Here I am instantiating an object of this class test public. This is the setter function. That means it is setting the value of that attribute to 2. Now there is no problem with these two statements, because the second statement is calling a public method, and public method can be called from the main program. Now this third statement, here I am calling the getter method, and this getter method is again a public method because I'm not using any special convention here, so by default it's a public method. So this method should produce an output, and it should set the value, it should actually print the value of this attribute public attr. So okay, here is 2 is the value that we set using that second statement. Now you see, in this fourth statement, what I'm trying to do, I'm trying to access that attribute directly from the main program. And we know that public attributes, they are accessible from the main program. So here I just want to show you that this can be accessed from the main program without any error. So this runs fine, and then I just want to see that whether the value has been changed to 99 or not. So I'm printing that attribute by directly accessing it. I could have used that getter method also, but here I'm directly accessing it to enforce that it's a public attribute and it can be accessed from outside. Okay, so 99 is the correct or is what we had expected. And lastly, I'm calling this method public method, and since it's a public method, I can call it easily, and it should print this particular statement, I am a public method, right? Now you might not find anything new here, because everything is public, all attributes and all methods are public. The point that I wanted to highlight here is that when all the methods and attributes are public, you can access them easily and freely from the main class. So we are accessing all the methods from this test code, and we are also accessing that specific instance attribute from this test code as well, and whole code is working absolutely fine. Now for protected attributes and methods, what we can do in Python is that we can use that single leading underscore convention. If you recall from previous slides, we discussed a naming convention, variable naming convention, in which we use a single underscore in front of a variable name. Now that's the only choice here in Python. We can use that convention to implement protected access. The problem here is that defining an instance variable that way, it does not effectively restricts a user from accessing a class attribute or a class method from the main program. Actually, it's just a hint for the programmer. Like, it's a kind of agreement between the programmers, between the coder of a class and between the user of a class, that since the coder is placing a single underscore in front of a variable name or a method name, that means that that particular method or attribute is for internal use only, and the user of the class should not try to access that attribute or method. But in reality, if the user of the class does not listen and he or she tries to access that restricted attribute or method, then that's fine with Python. Python doesn't raise any error on that. So that means that if you want to make an attribute or a method protected, what you do, you simply place a single leading underscore before a variable's name, right? So this will indicate to the user of your class that this is a protected attribute or a method, and it is for internal use only, and the user of your class should respect your decision. However, Python does not implement it strictly. If the user wants to access or tries to access that attribute or method, he or she is fully allowed to do that. Now let's see a small coding example on this too. Here I am defining a new class, test protected. Here I'll define those same three methods, just a change of names. Set protected attribute, it's a setter method, and it will set a protected attribute. So here is a protected attribute, and you notice here that I'm using that single underscore in front of that variable name. So underscore protected attr is my protected attribute. So a protected attribute, it can be accessed within a class. So this statement is perfectly fine. X will be assigned to underscore protected attr. I define a similar getter method here. This will simply return the value of this protected attribute or underscore protected attribute. And here is a protected method. And you see the name of this method is it starts with a single underscore. So that means that I want to make this method a protected method. Now, by convention, the difference between this last method and the previous two methods should be that the previous two methods, they are public methods, and this last method is meant to be a protected method, and a protected method should not be accessible from the main program. Similarly, if you talk about that protected attribute underscore protected attr, convention says that since it's a protected attribute, it should not be accessible directly from the main program. Like, you can access this variable through getter or setter functions, because getters and setters, they are public methods, but it cannot be accessed directly using that dot operator. So let's run some test code. Okay, this is instantiating an object p1 of this class type. Here I am calling this setter method. This is perfectly fine because setter method is a public method, and there is nothing wrong with this statement. And this third statement is again a getter statement, so that's also is a getter method, and that's also a public method, so it should print the value of that protected attribute. So the point here of using these getters and setters is that I have made my attribute protected. It should not be accessed directly from the main program, and if you want to access it, you have to use those getter and setter methods. Okay, now this statement here, what I'm trying to do, I'm trying to access that protected attribute directly. And by convention, this should not be allowed, because this statement is written in the main program or the global namespace, and this should not be allowed. P1 dot underscore protected attribute attr means that I'm trying to access a protected attribute. But as I told you earlier, that this is just a convention in Python. So the point here of putting this underscore before a variable name is that I'm just requesting the user, please don't use it. But if the user writes this statement, there is nothing wrong with it, and this statement will assign 99 to this attribute, this protected attribute. So if I now try printing it again, it should not be accessible from outside, but this is perfectly fine. It's printing 99. In other programming languages like C++ and Java, this does not happen. If you try to access a protected attribute from here, from the main program, that causes an error and that stops your program, right? But as I told you that Python does not agree with that logic. So this is just a way to emulate that protected feature, but it's not actually implementing it to the full strength, right? Similarly, here I'm trying to access a protected method. Conventionally, it should not be allowed, right? But there is nothing wrong with it in Python. It's printing that string, I am a protected method. So again, I would uh, recall that point, that if you are putting an underscore that actually does not implements protected mechanisms, but it's just a request to the user of your class that this is something that I have defined for internal use only, so please don't access it, and the user of your class should respect your decision. So this means that protected access specifier, it can only be implemented symbolically in Python. There is no way of enforcing this type of access in a program, in a Python program. For private access modifier, the situation is a little better in Python. We can use that name mangling convention here. Like if you want to make an attribute or a method private, you just place a double underscore in front of the variable name, and that will make that attribute or method private. In what sense it is private? That it is not, it cannot be accessed from the main program. And I told you about that name mangling convention, that if you place that leading double underscore with a variable name, then uh, a main program cannot access that particular variable and it will generate error. But there is a cheat trick here. Like if the user of your class knows that expansion name, or that expanded name, like how Python expands these such names which start with double underscore, then the user can access that. Otherwise, that variable name in its actual form cannot be accessed from the main program, right? So let me show you an example on this. Again, I'm implementing a similar test class here, and it is called test private, and I'll use the same format. I'll define one private attribute here, and I'll define two public methods, a getter method and a setter method, and I'll define one private method. So this is my first public setter method, and it will simply set x or assign x to a private attribute. So here is the private attribute, and how I'm making it private? By putting these leading underscores, two underscores, right? So double underscore private attr is a private attribute, and I'm just setting it through this setter method. Here is the getter method for this. It will simply return the value of that private attribute. And this is my private method. Now, since I have made it private, what I have done here, I have just placed a double underscore in front of that method name. So double underscore private method is a private method, and it will simply print this statement. Now, let's run some test code. This is the first statement in which I am instantiating an object P2 of test private type, right? This is the second statement. This is here I am calling the setter method, and since setter method was not a private method, so this statement should work fine. So what this statement will do, this will call this setter method with this parameter 44, and this 44 will be assigned to my private attribute under double underscore private attr, right? Now, this getter method is also a public method, so there is nothing wrong in executing this statement. It will simply return to me the value of that private attribute, which I set to 44 in the last statement. So the result of this last third statement, it should be that it should print 44 on the screen. Okay. Now, the fourth statement here, what I am trying to do, I am trying to access that private attribute directly from the main program. Double underscore private attr is a private attribute, and p2 through object p2, I'm trying to directly access it from my main program. Now if you run this like I have shown you here, this will generate an error. Like, you are not allowed to access any attribute which starts with a double underscore from outside the program directly. So this will generate an error. But if I try to access it through its expanded name, now you see this is the expanded name that Python will make for your private attribute. Underscore test private is the name of the class. So underscore name of the class, then comes then double underscore, and then comes the name of your attribute. So this is the expanded name for my private attribute. So if I run this is perfectly fine and this is accessible. So this is a cheat trick. If the user knows this expansion trick, then he or she can access your private attributes and private methods as well. Otherwise, they are not accessible from the main program. Now here I'm trying to access that private method. What should it do? It should obviously raise an error, because here I'm trying to access a private method which is starting from which is starting with a double underscore. So it will generate error. But if I expand this name to this convention, underscore name of the class, then double underscore name of the method, then it would work perfectly fine. Right. Now let me show you in idle what kind of errors are these, or what is printed when when I try to access a private attribute from the main program. Now here in idle, on the right hand side, we have that file, that code file that I have provided to you along with this lecture 7, and this is the code that I showed you on slide 12 to demonstrate, these private access specifier. I'll uncomment this code in parts, and let's run it and see what output it produces. So, okay, now if I run this much code, this should not produce any error, because I'm instantiating an object. That is absolutely fine. I am assigning my private attribute a value of 44 through this setter method. That is absolutely fine. And then I'm accessing the value of my private attribute using this getter method. That is also absolutely fine. So if I run this code, see, it prints 44, which is absolutely correct. Now if I uncomment this statement, now here I'm trying to access this private attribute. So according to my explanation, it should produce error. So let's see. Now here you can see it produces an error that this class has no attribute called private attribute, a double underscore private attribute. That means that this attribute double underscore private attr is not visible from the main program. So when I was trying to access it through this statement, it is producing error because that cannot be accessed from here. But I know this trick that if I expand this name to this complete name, like if I add underscore class name along with it, test private is the class name, then it should work fine. So let's see. Okay, I need to comment this one out because it was producing error. So now see, this is fine. First 44 is due to this first print statement, and second 44 is due to this second print statement. Similarly, if I try to access this private method directly, this will also produce an error. So here it is not identifying this attribute underscore private method. Actually, this term attribute is sometimes used for both the data items and for the methods also. So here this underscore private method is also not visible to this from this main program, accessible from this main program. So let's comment this out, and then using this cheat trick, I can access that method. Right? So now this method is executing fine and it is printing what it is supposed to print. I am a private method. Right? Now let's see a small practice problem where we can apply these concepts. Here we are supposed to develop a class called worker, and this worker class should have two private attributes: hours worked and wage rate, and these three methods: set hours worked, change rate, and pay. If you look closely, these two methods, set hours worked and change rate, they are basically setter methods for wage rate and hours worked. So um, they'll work just like those setter methods, right? Now when I start implementing this class, this is the first statement that I would write. And after that, I have to decide that whether I should make these attributes, hour works and wage rate, class attributes or instance attribute. So right now I am deciding that I'll make them instance attribute only. So I am not defining them initially in the class. So I'll directly go on to these methods. Set hours worked, this is a kind of setter method, so it will just assign this h to hours worked. But since I have to make this hours worked a private attribute, so therefore I put those double underscores in front of it, right? Similarly, this second function is a kind of setter function for wage rate, and this will simply assign r to the second private attribute, which is wage rate. And how it is a private attribute? Because I'm putting that double underscore in front of it. This is the third method. It will simply multiply these two attributes, these two private attributes, and it will return that value to the calling function. Now here in the problem, they did not ask us to make any private method. So all these three methods, they are public, right? Now what I want you to do is that just write some test code and see whether you can access these private attributes or not, and try using that expanded name convention, and see how you can access them. So that test code is for you to write. Okay, so that's all for today. Here's a quick recap of what we have done today. We discuss this underscore convention, naming convention that Python uses for at various occasions, and we saw that how these can be used. Then we discussed in a little detail what name mangling is and how it helps avoid conflicts in subclasses. Actually, we saw that it replaces the variable name with with an extended name, and that serves the purpose. And then we saw that these underscores, they can be used to emulate access specifiers, protected and private access specifiers, because the problem here is that Python does not directly support the concept of access modifiers, but we can emulate that to some extent using underscores. So for protected, we saw that it's just an emulation. It's not actually implementing the real thing, but it's a way of indicating that okay, these variables and methods are private, so please take care and don't use them in the main class. Whereas for private attributes and methods, there was a better way. We used the double underscore leading double underscore convention, and that worked to some extent. Like if the user doesn't know that extended name, then this will serve the purpose, right? So all these examples in this class, I wanted to show you that how these protected and private access specifiers work. Although they are not supported in Python, but other language, they support these concepts religiously. So you must know how these access specifier work, and what kind of access limitations they provide on attributes and methods. Thank you.